Hi everyone, today we are going to start learning how to simplify a rational expression. So first of all, we need to know what a rational expression is. So a rational expression is an expression that can be written as a fraction. So it's pretty much a fancy way to say a fraction. So to simplify a rational expression, the first thing you're going to do is factor if possible. Now sometimes you can't factor, so you can skip step one. Then you divide out any common factors from the numerator and the denominator. So anything that's the same in the numerator and denominator will cancel out. And the last one is going to be something kind of new. We have to list excluded values. So we pretty much have to say what our variable cannot be. And this, the one thing we have to keep in mind when doing this is that our denominator cannot equal 0. It's impossible to divide by 0. So we pretty much have to figure out what values would make our denominator 0, and that's what we can't use. Okay, so here are 3 examples where you don't need to factor, so we're just going to cancel out common factors. So here we have 12 over 2x squared. Now if it helps, we can rewrite 12 in fully factored form. We can rewrite 12 as 2 times 2 times 3. Those are the factors. You can get that just by doing a factor tree. And 2x squared in the denominator can be written like this. Then we look for common factors. So there's a common factor of 2, which means our answer is 6 over x squared. So this is the simplified form. And since we have x in the denominator, we're going to say, well, x squared cannot equal 0. Because our denominator cannot equal 0, and then we solve for x. So we essentially would take the square root of both sides, and the square root of 0 is 0. So we have to say that x cannot equal 0. This is what we call a restriction. So it works for any numbers except when x is 0. Now let's look at part B. So remember, factors are things that are multiplied. So when you have something like this, like n plus 8, we want to actually put parentheses around it to group it. This is a single factor. So I understand that they both have n, but n is not the factor here. N plus 8 is the factor. So in this case, we actually cannot simplify. So again, if there's a plus or minus sign, we have to group the numbers together. Factors are when you have only multiplication. So we cannot simplify, but then remember we still need to list our restrictions. So we know that whatever is in our denominator, n plus 8, it cannot equal 0. And then we solve. So we subtract 8 on both sides, and we know that n cannot equal negative 8. This is our only restriction. So negative 8 is the only number that is not allowed. Everything else is fine. All right, and for this last one, let's list out our factors. So 3 is just 3. And remember, y squared we can list as y times y. And then in our denominator, 6 we can write as 2 times 3 if it helps. And then we have times y times, and then group together y minus 7. So y minus 7 is an entire factor. So now let's start canceling out common factors. I see a 3 and a 3. Then I see a y and a y. So if I write what I have left, it's y divided by 2 times y minus 7. Again, I can't cancel these out because this y is part of y minus 7. The entire thing is a factor. So unless the entire thing matches, I can't cross it out. So here, we have to look in our denominator and we have to say, okay, this cannot equal 0. Because our denominator cannot equal 0. So y minus 7 cannot equal 0. And then we just kind of solve as if it's in a normal equation. So we know that y cannot equal positive 7. And that's our only restriction. So again, we wrote it in factored form. We canceled out common factors, and then we found our restrictions by setting our denominator not equal to 0. Okay, let's try a couple where we have to do that step 1 where we factor. So in example A, we have x squared minus 1, and then we have over x minus 1. So x squared minus 1, we can actually factor using difference of two squares. So if you remember, the difference of two squares was that a plus b times a minus b when you have subtraction with two perfect squares. Remember, 1 is a perfect square. So you can factor and it becomes x plus 1 times x minus 1. That's the factored form of x squared minus 1. Our denominator will stay x minus 1, and notice I put parentheses around it to show that it's a single factor. Now here, look, I share the factor x minus 1 in the numerator and denominator, so those can cancel out, and what I have left is x plus 1. Now, even though this got canceled out, we should still go back and list it as a restriction. We should say x minus 1 cannot equal 0, so x cannot equal positive 1, just so our original equation is still valid. But this is the simplified form. This is what x cannot be. All right, let's look at this last example. So both the numerator and the denominator here can be factored using magic x. These are trinomials, and the a value is 1. So we're going to do magic x for the top first. So what multiplies to make negative 12 and adds to make positive 1, we can use 4 and negative 3. So here my factors are x plus 4 times x minus 3. And then to factor my denominator, we'll do another magic x. So what multiplies to make negative 20 and adds to make negative 1, negative 5 and positive 4. So our denominator becomes x minus 5 times x plus 4. So we can see that there is a common factor of x plus 4. So that will cancel out, and what we have left is x minus 3 over x minus 5. This is the simplified form, but we still need to find our restriction. So both of these factors, it's kind of like doing the zero product property. We need to make sure that neither of them become 0. So x minus 5 can't be 0, and x minus 4 cannot be 0. So we get x cannot equal positive 5. That's one restriction that will make our equation invalid. And then x cannot equal negative 4, which would make our expression invalid. So those are the only two x values that don't work. And again, this is our simplified answer. These are the restrictions. Okay, go ahead and pause the video and give these 3 examples a try. All right, go ahead and check your work. So see how I wrote in factored form for part A, 7 canceled out, x canceled out, and what I have left is 3 over x. X cannot equal 0. For part B, d squared minus 4 can be factored into d plus 2 times d minus 2. That's difference of two squares. D plus 2 is a common factor, so this is my final answer. However, d plus 2, this cannot equal 0, which means d cannot equal negative 2. And for part C, you can see that we can factor both using magic x. So we get x minus 3 times x plus 2 in the numerator, and x minus 9 times x plus 2 in the denominator. X plus 2 cancels out, and we're left with this as our answer. However, this factor cannot equal 0, so x cannot equal 9. And this factor also cannot equal 0, so x cannot equal negative 2. All right, that's all for today. Thank you so much for watching.